Welcome to this computer hardware engineering video of Refreco's company channel. The channel focuses usually on software engineering themes, but here we have a computer hardware engineering topic. However, this video introduces a design of a new powerful server which is based on a notebook CPU, and on the other hand you learn something about the architecture of the Linux Proxmox data center including Ceph. Let's start immediately after the intro so that you guys know what Refreco is standing for. Short disclaimer for the video: none of the shown hardware stuff in this video is sponsored in any kind by the according vendor or manufacturer. We have bought all the components from our money. So the question is, what are the requirements for the project? It's requested to create a server infrastructure for a small office, like most of you have set up in your homelabs too. And this means creating a solution for storage and running virtualized services like TrueNAS, Nextcloud, VaultWarden, GitLab and so on. Having this defined, I compiled the main requirements to these bullets. So there is high availability requested, powerful virtualization and services for 24/7. A couple of spinning disks are needed and the budget is limited to 1,000 euro. The leanest design approach for such a server architecture is a Proxmox cluster with only 2 operative nodes configured with Ceph. Each node holds the same data as the other does. To match the budget constraints, I'm using an already existing server hardware, and additionally I designed a new one, which is a second scope of this video. The new one will have a notebook CPU and is therefore less power consuming. Usually the smallest Proxmox cluster needs at least 3 nodes and switches, but here we implement the Quorum service on a legacy NAS, which I have in my lab for a couple of years. This is the architecture for the server environment. Each motherboard of node 1 and node 2 does have a NIC, and these NICs are used for the PVE management network. This is on VLAN 400 and it is for managing the Proxmox cluster only. Isolating this network from all the other is a cybersecurity benefit. Next, there is a Ceph public network on VLAN 200. For performance reasons, it is provided on a 10 gigabit NIC. In other words, every client in the office could be connected on a 10 gigabit Ethernet connection, which is state of the art. The last VLAN is just for the Ceph cluster network, and this is realized as a point-to-point connection from node 1 to node 2 in a separate VLAN 999. Ceph is needing this internally. No router is needed here, which makes the design lean and cheap. Now it's time to explain the newly designed server. Let's have a look at the bill of material. These are the components. I decided to search for a 2-unit rack chassis which can pick up sufficient 3.5-inch hard disks, and decided to purchase the RM21-308 from Silverstone Tech, while knowing that this is not the cheapest offer for such a case. In terms of the motherboard, I decided to select a motherboard which fulfills a huge feature set and matches the budget. I choose the BD790i from Minisforum. It has a high computing power due to the total amount of 32 threads. The only thing which is missing here is ECC. As far as I found out, the CPU is supporting ECC, the motherboard isn't. Most important for this design is the riser split card for PCIe 16 to 4 M.2 ports. This is enabling anything else by splitting up the 16 lanes of the single PCIe slot into 4 × 4 lanes. Please keep in mind that the BIOS must be configured accordingly. I'll show this later. For connecting the hard drives, there are 2 SATA adapter cards placed on the double-sided riser split card. Then there is the network connector card, which is a dual 10 gigabit Ethernet card. I selected one which has a X540 controller on it and was sure that it is working with Proxmox out of the box. For connecting the double 10 gigabit card, I used the ribbon cable which brings the 4 lanes of the M.2 to the Ethernet card. The chassis provides room for an ATX power supply. In my case, a 550 watt power supply from Be Quiet went into the server chassis. The most important component in a server is its CPU and motherboard. I have chosen the motherboard from Minisforum, the BD790i, which includes an AMD Ryzen 7000 series CPU. It is a mini ITX motherboard, is PCIe 5 ready and has heatsink and full customized cooling concept included. It comes with a pre-mounted AMD Ryzen 9 7945HX, which is a 16-core 32-thread CPU with 64 MB cache. Bus speed is up to 5.4 GHz. The CPU does have an AMD Radeon 610M included, and it does support DDR5 dual channel memory by plugging in 2 SODIMM modules running up to 5200 megatransfers per second. For RAM I placed 2 32 gigabit modules on the board because this was recommended, but I have noticed that other homelabs are using 2 64 GB SODIMMs without having any problems. The system storage of this motherboard provides 2 slots for M.2 2280 SSDs. I placed 2 1 TB from Crucial there and used it for system storage in Proxmox in a RAID 1 configuration. The motherboard also has built-in Wi-Fi, which I don't use. Next, let's have a deeper look at the periphery components in this server. However, there is just one physical PCIe 5 slot with 16 lanes on the motherboard. This is one single PCIe which is usually supposed to pick up a graphic card. The CPU does have 22 lanes, and the question is how to distribute the 16 lanes efficiently. According to my setup, I updated the configuration of the BIOS. It's possible to map the 16 lanes as 4x4x4x4 lanes. Next topic is to wire up the dual 10 gigabit Ethernet card. Let's have a look at the funny ribbon cable thing, which has an NVMe connector at one side and a PCIe connector at the other side. Mounting it is quite simple because it is plug and play. Okay, always important is to calculate the bandwidths. Let's have a look on it in terms of the dual 10 gigabit Ethernet card. A dual port card requires 20 gigabits per second in total, which is equal to 2.5 gigabytes per second. Let's have a view on what we can achieve by using a bundle of 4 lanes. PCIe 3 is sufficient for a dual 10 gigabit Ethernet card, but only with a buffer of 58%, which could be limiting in high traffic scenarios with additional overhead. PCIe 4 provides sufficient bandwidth, around about the double of what's totally needed. It is exactly what is applied here, and I found out that it ensures a smooth performance. PCIe 5 is overkill, over 5 times of required bandwidth, so there is no need to focus on it. There are 2 rows of HDDs in the chassis, and each row has 4 disks. One row is connected by its own SFF port on the back plane. For this reason, I put 2 SATA adapter cards on the double-sided riser card. 4 SATA ports on each controller are used, 2 are left open. Let's do the bandwidth calculation for the 4 SATA spinning disks. Each SATA port has a maximum theoretical speed of 6 gigabits per second, which is equal to 750 megabytes per second. Or in other words, the 4 disks connected on the M.2 port requires 4 times 6 gigabits per second, which are 24 gigabits per second, and this is equal to 3 gigabytes per second. The conclusion is PCIe 3 is sufficient for 4 SATA disks but has only a buffer of 31%. In real-world use, factors like protocol overhead and simultaneous read-write operations could cause slight bottlenecks. PCIe 4 is more than enough. A buffer of 163% of additional operation is very good. And also PCIe 5 is complete overkill, which we don't need and we don't use. Thus PCIe 3 would be okay, but PCIe 4 is preferable for high performance setup. And this is what we achieved here. In case there are 6 SATA drives connected instead of 4 drives, I guess this runs without any problems. I measured by using the Blackmagic Design disk speed tool on a true NAS, which is realized in Proxmox VM, and got a writing speed of 909 megabytes per second, and reading was about 940 megabytes per second. These values are pretty good in my opinion. For connecting the SATA ports to the backplane in the chassis, you must carefully choose your cable. There are 2 types of cables for the SFF-8087 connectors. A host bus adapter, like the very popular Megarate SAS 9240, for example, is using electrically different cables. Those won't work. I use the CPS03-RE from Silverstone Tech, and they are working like expected. There is one option I want to introduce here, but it is totally unapproved. I placed a 2 TB SSD on the 4th M.2 slot of the double-sided riser card without having a clear idea of using it. But instead of this, it might be a good idea of placing an Oculink M.2 card there and connect an externally placed graphic card. I would use this for locally running LLMs. Bandwidth has to be considered anyway, but this is just an idea, and if you like, you can discuss this in the comments underneath the video. I appreciate to get your ideas. I don't want to lose too many words on the 4-unit server, which is also a DIY server. There is nothing special. The list of components is visible here. The only thing which I added there for the project is the HBA for the SATAs, a dual 10 GB adapter, and the case for the 5 spinning disk, also from Silverstone Tech. I found out that this old boy is still running Proxmox without any trouble. It has 128 GB of RAM, and I can upscale this up to 512 GB. Also, there is a possibility of putting another CPU on the second socket. Okay, not to forget the 3rd box of the Proxmox cluster. Basically, it is just for satisfying the Proxmox Quorum criteria. A VM on any box in your data center can do the same. Okay, this is all about the hardware which you should be aware of. Hopefully this is a nice inspiration for your home lab too. Let's have a quick overview on the remaining software topics. These are setting up Proxmox cluster, installing a VM on a NAS for achieving the Quorum, creating a Proxmox virtual bridges and network configuration, and finally setting up Ceph for the Proxmox data center. However, I decided not to cover this in this video clip because it would get too long, and long mostly means boring. In case you are interested in this topic, please let me know it in your comments underneath the video, and please like the video and subscribe to the Refreco channel in order not to miss the second part of the video. After the last slide follows the very last slide. Thanks a lot for watching, and in case you found this video on a suitable engineering quality, please subscribe to the channel. And in case you have your own ideas about this approach, please feel free to comment. I'm happy to read something about your thoughts. The company Refreco provides support for your software development projects of any industry, and it doesn't matter whether your projects are phase-driven or based on agile frameworks like Scrum or Ceph. See you next time.